Right now, as you watch this video, there are over 30,000 near-Earth asteroids being tracked by scientists. And here's the terrifying part. We're still discovering new ones every single week in 2026. What would actually happen if one of these space rocks hit our planet? Not the Hollywood version. The real, scientifically accurate chain of events that would unfold. Because the truth is way more complex and in some ways more terrifying than any movie has ever shown you. And it all depends on one critical factor. I'm about to walk you through exactly what would happen from the moment of impact, minute by minute, based on real scientific data from actual meteor strikes throughout history. And by the end of this video, you'll understand why NASA just invested over $300 million in planetary defense systems this year. First, we need to understand that not all meteors are created equal. Size matters a lot. We're talking about the difference between a broken window and the extinction of humanity. Let's start small. A meteor the size of a car enters Earth's atmosphere about once per year. Most burn up completely before reaching the ground, creating spectacular fireballs in the sky. But here's where it gets interesting. Once you hit about 20 meters in diameter, roughly the size of a house, now we're talking about city-level destruction. These impact with the force of a nuclear weapon. We're talking hundreds of kilotons of TNT equivalent, and they hit Earth about once every century. At 1 kilometer across, you're looking at a global catastrophe, civilization-ending potential. These strike roughly every 500,000 years. And anything above 10 kilometers? That's the dinosaur killer category. Now here's what keeps scientists up at night. We've only cataloged about 95% of the near-Earth asteroids larger than 1 kilometer. That means there are still massive ones out there we haven't found yet. Let me tell you about February 15th, 2013. A normal Friday morning in Chelyabinsk, Russia. Then the sky exploded. A meteor just 20 meters across entered the atmosphere at over 60,000 kilometers per hour. That's 18 kilometers per second. Faster than anything humans have ever built. The air in front of it couldn't get out of the way fast enough. It compressed and heated to temperatures hotter than the surface of the sun. The meteor itself started to glow like a second sun in the sky. Then it exploded with the force of 30 Hiroshima bombs. The shockwave shattered windows across 6 cities. Over 1,500 people were injured, mostly from flying glass. And here's the absolutely wild part. Nobody saw it coming. Not NASA, not the Russian Space Agency. Not a single telescope on Earth detected this thing before impact. It came from the direction of the sun, where our telescopes are blind, and it was relatively small in cosmic terms. A space pebble, but it still caused more damage than any meteor in over a century. Chelyabinsk was a wake-up call. It proved that even small impactors can cause massive damage to populated areas. And we need to be ready. So let's walk through what happens when a truly large meteor hits Earth. Not 20 meters, not 100 meters. Let's go big. 1 kilometer across. A small mountain falling from space. The instant it makes contact, everything within 10 kilometers is vaporized. Not destroyed, not blown apart. Vaporized, turned into superheated plasma in microseconds. The impact creates an explosion measuring hundreds of thousands of megatons. That's thousands of times more powerful than the largest nuclear weapon ever detonated. A crater 20 kilometers wide opens up in seconds. But that's just the beginning. The real killer is what happens next. Within 1 minute, an atmospheric shockwave races outward at supersonic speeds. Everything within 200 kilometers faces winds stronger than any hurricane ever recorded. Buildings, trees, everything gets flattened. The heat from the fireball ignites fires across 1,000 kilometers. Anyone with a direct line of sight to the impact gets third-degree burns from the thermal radiation alone. But we're still not done. Millions of tons of vaporized rock and debris get thrown into the upper atmosphere. This is where the global effects begin. Within hours, this debris cloud spreads across the hemisphere. Within days, it encircles the entire planet. Sunlight gets blocked. Temperatures drop. And they keep dropping. 66 million years ago, an asteroid 10 kilometers across hit what is now Mexico's Yucatan Peninsula. The Chicxulub impact. This is the gold standard for how bad it can get. The impact released energy equivalent to 10 billion Hiroshima bombs. It created a crater 180 kilometers wide. Earthquakes measuring magnitude 11 shook the entire planet. Tsunamis over 100 meters tall devastated coastlines on every continent. But the dinosaurs didn't die from the impact itself. They died from what came after. The debris cloud blocked out the sun for years. Photosynthesis stopped. Plants died. Herbivores starved. Carnivores followed. 75% of all species on Earth went extinct. And here's the kicker. Recent research in 2026 has shown it was even worse than we thought. The impact vaporized massive sulfur deposits, creating acid rain that poisoned the oceans for decades. But there's a silver lining to this prehistoric nightmare. That extinction event cleared the way for mammals to rise. Without it, humans would never have evolved. We literally owe our existence to an asteroid impact, which makes it deeply ironic that another asteroid could end us just as easily. So what happens if we detect a large asteroid heading our way? Could we actually stop it? The answer might surprise you. NASA's Planetary Defense Program has been quietly working on this exact problem. And in September 2022, they pulled off something incredible that changed everything. The DART mission, Double Asteroid Redirection Test. They deliberately crashed a spacecraft into an asteroid moon called Dimorphos at 24,000 kilometers per hour. The goal was to change its orbit, and it worked, better than anyone expected. The impact altered Dimorphos' orbit by 33 minutes. We can literally push asteroids around. This proves the concept of kinetic impactors. If we have enough warning time, years or decades, we can nudge a threatening asteroid onto a safe trajectory. But here's the catch. We need early detection. The earlier we spot a threat, the smaller the nudge required. Wait too long, and even our best technology becomes useless. That's why NASA and international partners are launching new survey telescopes right now in 2026. The goal is to find every potentially hazardous asteroid before it finds us. We're also developing backup plans, gravity tractors that can slowly tow asteroids, nuclear options for last-minute deflections. Yes, nuking asteroids is a real strategy on the table. If you found this video mind-blowing, smash that like button and subscribe to your Space Wizard. We make the universe accessible and absolutely fascinating every single week. The good news is that a civilization-ending impact is extremely unlikely in our lifetimes. The odds are literally astronomical, but the threat is real enough that scientists take it seriously. And unlike our ancestors who could only watch the sky helplessly, we have the technology to actually do something about it. We're the first generation in Earth's history with that power. So the next time you look up at a shooting star and make a wish, remember that humanity is working hard to make sure those streaks of light stay beautiful and harmless. Because we're not just hoping for the best anymore. We're actively defending our planet. And that might be the most incredible thing of all.